So let's go over trig substitution, okay? Integration. So we can't use integration by use substitution, yeah? We can't use partial fractions by parts. So let's answer this question. So I told you to say whenever you want to integrate by trig substitution, connect whatever you have as a radical. So if you look at the square root here, we have got the square root of 9 minus x squared. So take the constant always to just be a 1, and then the other part of x to be a trigonometric function. So what kind of an identity are you forming there? If you go back to sine squared plus cosine squared of theta is equal to 1. So we're going to have 1 minus sine squared of theta, okay, being equal to cosine squared of theta by just taking sine squared on the other end. So therefore, wherever is x, we're dealing with sine theta, right? So that's how you remember what substitution to perform. Okay, that's just a tip for you. So therefore, in this case, we're going to let our x be equal to, remember it's always going to be our a over our b, right? And then in this case, we determine we're dealing with sine substitution. Now, I said the b is always the number that is attached to the trigonometric function, and then a is the one away from the trigonometric function. So if we write our square root there, or our radical 9 minus x squared in the form of squares, so we're going to have 3 squared minus, since we don't have a coefficient, we just put 1 squared on the x part. So therefore x becomes, our a is the one away from the function, so it's 3 in this case, and then our b is the one attached to what? To the function, which is just a 1 in this case. So this becomes our value of x for this substitution. Okay, so always remember what we substitute is x is equal to a over b, where b is attached to the function, and then here it can either be sine, it can be secant, so far what we've talked about, and of course later on we'll see that we can also put tan in a case where we've got addition. Okay, I think that summarizes everything. So let's proceed now and perform the substitution. So we need now to substitute the value we have, which is 3 sine of theta, in the function we have. So we know that we need to put x squared. So what is x squared? So if we square our x, it's going to be 9 sine squared of what? Sine squared of theta. That's what we need to know. And then let's do that. Let's substitute. And then we also have x to the power 4 somewhere there. So x to the power 4 again, it means, think of it as we're squaring the x squared. So 9 times 9 is what? Is it 81? And then sine the power 4 of theta. Okay, so there we are. We can now substitute. So let's ignore the integral for now. So we have 1, and then for the x to the power 4 we have 81 sine squared, sine actually to the power 4 theta, and then we have got a square root of 9 minus our x squared, which is 9 sine squared of theta. Okay, so let me draw a longer line there for the, and then you can center the one a bit. So we have 1 over that. So we've just substituted the value of x everywhere. Okay, we just substituted the value of x. Now, knowing that we're dealing with an integral here, let me put back the integral so that we can pull out 1 over 81 on the next step, since 81 is the coefficient on the bottom and 1 on top. So we just have 1 over 81, and then on top we remain with a 1 again, and then here you're going to remain with what? It is going to be sine the power 4 theta, and then under there we've got a square root, right? So how can we undo it? This is the way we can undo it. So we can factor out a 9 there, so that we have 9, and then you remain with a 1 for a part where we've got 9, and then again there you just remain with sine squared of theta, right? So don't forget there's dx at the end, so dx and then dx. And then on the next stage 1 over 81, the integral of 1 over, so we have sine 4 theta. So we can find the square root of 9. Square root of 9 is just going to be a 3. So a 3 can move out of a square root. And then we remain with a square root of what? So sine squared of theta, 1 minus sine squared of theta is the same as what? Come on, come on, come on. So that's the same as cosine square of theta. These are some of the identities that I believe you already know. Okay, so don't forget about what we've said our x is equal to. Our x is 3 sine theta. Let me just write somewhere there. Okay, so anything else that you're able to see that we're able to simplify at that point? Okay, so let's move. So we have 1 over 81, and then we have the integral of that. So we can do away with a square root. So a square root of cosine square of theta, I'll take a positive answer, so that we have sine 4 theta. So the 3 can actually become the coefficient there. 3, let's have 3 somewhere. So we have a 3, and then sine 4 theta, and then we just have like multiplied by cosine of theta. So don't forget we have dx attached. So since we've dealt away with the square root, let's now find our dx there. So don't forget that our x is initially equal to 3 sine theta. So if we try to determine the derivative of x, so our dx is going to be 3, and then what's the derivative of sine? It's cosine theta. So that's in respect to theta. So we can substitute now. So we have 1 over 81, the integral of 1 over 3 sine the power 4 theta multiplied by cosine of theta. Now for our dx, we have 3 cosine of theta d theta. So what do we have? Cosine of theta can basically divide by cosine of theta, right? Okay, which also tells us at that point we can also do away with the 3. So we can move to the next stage. So the next point what we have is 1 over 81 put away from the integral, and then the integral of 1 over sine the power 4 of theta, and then of course the theta in respect there. So think of something that can make this simple. Instead of dealing with fractions, we can deal away with a fraction. So I believe you know that 1 over sine theta is what? 1 over sine theta is what? Cosecant of theta. So therefore, whatever power you have, it can still happen. So that would mean we can have 1 over 81, and then the integral of cosecant, okay, the power at 4 theta d theta. So that's how we've reduced, that's how much we've reduced it at this point. So are you getting any closer to a point where you're able to answer the question? So now we can now try to perform the integral. So you can see it's a bit tricky for us to just perform the integral directly there, because we don't know the integral of that. So how about if we try to break this one down into 2? We can deal with it in terms of squares. So we have 1 over 81, and then the integral of, we can have cosecant square of theta multiplied by cosecant square of theta. We've just like split the theta into 2. Okay, and then we can try to substitute. We know that from our initial identity, of course, we know that we can come up with cotangent squared of theta plus 1, okay, being equal to cosecant square of theta by just dividing by sine square of theta throughout the entire, just this basic identity. Okay, that's why we get that. So just divide the entire equation by sin square of, by, actually what are we dividing by? Yeah, we're dividing by sin square of theta. You get that. So let me substitute. So we have 1 over 81, and then at one point we can put, for the first part, cotangent square theta plus 1, substituting the first cosecant, and then we've got cosecant squared theta, of course in respect to theta there, right? So at this point, is there any way we can simplify this? So we can try to find the ways and means of just dealing away with this part, the cosecant squared theta. How can we remove it? So we can use again another form of substitution. Let's use u. So if we let our u be equal to cotangent of theta, which is the one that has just come in there, if we let our u be equal to that, and then we try to determine the derivative of that. So our derivative is going to be negative cosecant squared of theta. Okay, d theta. So where we've got a d theta, I can just substitute. So we're going to have 1 over 81, and then the integral of cotangent square of theta plus 1, and then cosecant square of theta. So where we've got d theta there, we can actually make d theta the subject. So if d theta becomes the subject, we're going to divide both sides by negative cosecant of theta. So our d theta therefore becomes du over negative cosecant square of theta. So we can substitute where is d theta there, where was this part, so we can put du and then over negative cosecant square of theta. So don't forget now, since we are putting that, we are saying our u is equal to cotangent of what? Theta. So where is cotangent of theta, I can put a u then plus 1. So you can see now the plan there was to do away with this part. Okay, so the negative can just be put out, so that we just have a negative 1 over 81, and then remain with the integral of u plus 1 in respect to u. So at this point, we can easily integrate that part, right? Or we just have a u. So we're going to have negative 1 over 81. So what's the integral of u? We have to add the 1 to the power, it becomes 2, divide by the result. Is that what we do? Integrate it. Yeah, so the integral of u squared. So the integral of u is going to be u to the power 2, right? And then of course over 2, and then plus 1 there. So 1 is going to be the integral of u. By the way, let's not forget that here in fact I made an omission. It was cotangent squared, not just cotangent theta. It was cotangent squared. So initially we had a 2 there. So this is also supposed to be a 2. So that as we get to integrate there, it's supposed to be adding a power. It's supposed to be the power 3, and then we divide by the result 3. Okay. Sorry for that. And then we've integrated this in respect to our u, right? So if we take back now our u, we know that our u is equal to cotangent of theta, right? So we're going to have negative 1 over 81, and then we have, so we've got coefficient of 1 over 3, since we've got by dividing by 3. Well, let me just write it the way it is. So for our u, we have cotangent, okay, over 3 plus our u, which is also cotangent of theta. Let me write that properly. Cotangent of theta, and then plus a constant c. So don't forget that our question started with us with a value of x, right? So we have to, it's mandatory that our answer needs to end up with in the form of x. So let's do just that. So that is our x is equal to that. So let's make sine theta the subject. So just divide by 3. So we're going to have x over 3 and then equal to sine theta. So we know that sine theta is equal to opposite over hypotenuse from SOHCAHTOA. So we can come up with a triangle, a right angle triangle. So if we have a 90 there, it means the hypotenuse is this side, hypotenuse is on the bottom, so 3. And then the opposite, taking this to be angle theta, the opposite becomes x. So this side is going to be, according to Pythagoras theorem, the square of the hypotenuse is equal to the squares, the summation of the squares of the other two sides. So let's say s squared plus x squared. So if we try to make s squared the subject, we're going to have 9 minus x squared, and then s becomes the root of 9 minus x squared. So this is what we have on this end, 9 minus x squared. So if we try to substitute in the equation that we have, we can see that what we have is a cotangent of theta. So what does cotangent mean? Cotangent is just a reciprocal of tan, right? Cotangent is the same as 1 over tan. So we know that we can easily find tan from, or in other terms we can go direct actually. 1 over tan is the same as the reciprocal of sine over cosine, which is just cosine over sine. Now I feel that is going to take time. Well, you can do that, but let's take it as just a reciprocal of tan. Since we know that tan theta from SOHCAHTOA can be found. So what is opposite over adjacent? So the opposite is x, and then the adjacent is the root of 9 minus x squared. Now, it being cotangent is a reciprocal of tan, so therefore it's going to be our cotangent, therefore becomes the square root of 9 minus x squared over x. And then you can get back to our equation and try to substitute that in. So we have negative 1 over 81. And then for this part, we have the root of 9 minus. So let me actually pull out the 1 over 3. So this 3 that is on the bottom, I can just pull it out. So 1 over 3. And then open brackets, we have now the root of 9 minus x squared over our x. Now this is raised to the power now. So that is raised to the power 3. And then plus cotangent of theta, which is just going to be now root of 9 minus x squared over x. So in brackets, plus constant c. Okay? So this is the form where we've ended. We can still decide to simplify it beyond this point. So let's simplify this. If we look at the square root that we have here, the root of 9 minus x squared, square root is the same as the power 1 over 2. Okay? And then let's multiply this with everything that is inside there. So I'll start first of all by multiplying the 81 by the 3. So 81 times 3 is 243. So we're going to have negative 1 over 243. Okay? And then this 3 times that power half is going to be 3 over 2. So I have x minus, so it's actually 9. 9 minus x squared raised to the power 3 over 2. And then divided by, so after raising, of course, since this entire term is raised to the power 3, you understand that even x is going to be the power 3. Okay? So we can just actually move the 1 and then just take the 243 to the bottom. So we have negative 243x to the power 3. And then after multiplying this again by this other part, we're going to have negative 1 over 81. So for the top part, we can just maintain the square root, right? So we'll have the square root of 9 minus x squared, and then on the bottom we can just put the 81 coming from the coefficient, so 81x, and then plus a constant c. So this is our final answer. Okay, so for your practice, I want you to try out this question. The integral of the square root of 9 minus x squared divided by x squared in respect to x. So pause the video and try this question out. Okay, so if you've answered, the expected result is 9 minus x squared over x minus sine inverse of x over 3 plus c. So continue trying out until you find this result. If you've got issues, give me a comment in the comment section.